Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section of the class, we're going to cover a topic that everybody studies in calculus and a lot of people have problems with. And that section is called L'Hopital's rule. So if you look in your book and you look at the title of this class, this title of this section here on the screen, it looks like it's L'Hospital's rule. And so you might be tempted to call it that, but the actual pronunciation is a French guy, and so you pronounce things a little differently, and it's called L'Hopital's rule, okay? So it's named after the person that discovered it. It's really cool, but the good news is it's really easy once I explain it to you. Let me give you a little bit of background, a little bit of motivation. Way back at the beginning of Calculus 1, usually the first thing you study is limits. They go into excruciating detail about limits, even before you talk about a derivative. Now, my calculus DVD doesn't start off that way, but most of the textbooks do. And usually in that section on limits, there's a bunch of limits that you have no way of figuring out the answer to, because usually you've got a limit of something over something else, and when you evaluate it as you go off to infinity, usually they're asking you to evaluate something as you go to infinity, okay? You get infinity on the top of the fraction and infinity on the bottom. Usually it's something like this. And so you have no idea what to do. And way back at the beginning of Calculus 1, because remember, this is like the first section of Calculus 1, they usually devote pages and pages of proofs and drawings to show you why this limit converges, okay? Well, it turns out L'Hopital's rule could do that limit in 2 seconds. Okay, it's really powerful and it's really easy. So really the bottom line big picture of what this section is going to be, it's going to teach you a method to evaluate limits that aren't so easy to evaluate just by plugging in the number, okay? And it's going to be really easy. So let's get a little bit of motivation for you here. Let's do some limits that I think you can do. Okay, what is the limit of, let's say, x approaches 0 of the limit 1, or of the function 1 over 2 plus x. Okay, this is not a trick question. I don't have trick questions in this class, so just look at it and tell me what you think. You have 1 over 2 plus x. If you approach 0, if you take x and you approach 0, then eventually this little position here is going to become 0, so 2 plus 0. So it's just going to be 2 on the bottom, right? So this limit is just 1/2 as x approaches 0. That's something that you learned way back in the beginning when you learned what a limit was, okay? So that's easy. Now what if you have a limit, limit of x approaches 0 of something like x over x squared? Now, okay, your first thought would be, well, let me go ahead and plug in x. So I've got x on the top, so I'll put 0 on the top, x squared on the bottom, I'll put 0 on the bottom. So what we say is this has the form of 0 over 0. Okay, because when you put x is equal to 0 in the top, you get 0, and when you put x is equal to 0 on the bottom, here you have 0 squared, that's 0. So 0 over 0, what does that evaluate to, I ask you? What does that evaluate to? 0 over 0. How do you do it? Does the 0 on the top trump the whole thing and make the whole thing go to 0? Because when you have a fraction, anything on 0 on the top will make it go to 0. Or is it go off to infinity because the bottom is 0, so you're dividing by nothing. So what wins, okay? So you really don't know how to evaluate this. You don't have the mathematical tool bag yet to figure out how to do that. We're going to tackle these kinds of problems in this section. Let me ask you one more question. What is the limit as x approaches infinity of 2 to the power of x over x squared, okay? So, again, what you want to do is you want to take infinity, because x is approaching infinity, plug it in here. Okay, so what you're going to have is 2 to the infinity power, right? And then on the bottom, you're going to have infinity squared. So those are both big numbers, right? So you're going to say it's still the same form. It has a form of infinity over infinity.